In this video, we're going to be talking about the mole and Avogadro's number for chemistry. So the mole seems like a very confusing topic for many students, but you actually realize that it's very similar to a lot of the terms we use in our day-to-day lives. So I'll give you an example. 1 dozen eggs means we have 12 eggs. A dozen is a way of counting or grouping eggs, right? I'll give you another example. 1 pair of socks means we have 2 total socks. Again, pair is a grouping for socks. And last example, 1 decade means there's 10 years, where decade is used to group or count years in groups of 10. So the mole is exactly the same. 1 mole, instead of being a small number like 12, 2, or 10, is 6.022 times 10 to the 23 of whatever you're referring to. So it's the exact same thing. If I had 2 dozen eggs, that's 2 times 12, which is 24 eggs. If I had 5 decades, that's 5 times 10, 50 years. So if I had 5 moles of electrons, that would be 5 times 6.022 times 10 to the 23 electrons. So the mole can be used to quantify anything. So it can be used to quantify electrons, protons, but most commonly it's used to count atoms and molecules. And I also want to clarify that this number, 6.022 times 10 to the 23, is known as Avogadro's number. But you can essentially think of the mole and Avogadro's number as the same thing. So why is the mole used? There's 2 main uses. The first is to translate between the atomic world and our world, or the macroscopic world. And so this is mainly done from converting AMUs, or atomic mass units, which weigh essentially atoms and molecules, to grams. Or converting grams to AMU. The second main use is to count large amounts of atoms. So you may have heard before that a single drop of water has millions, if not billions, of individual water molecules. And so if you wanted to count all of those water molecules, using numbers in the millions or billions would just be very tedious to write out. So that's where the mole comes in. The mole helps us count all of those large numbers of atoms and helps us group them together. And this works because the mole is such a big number, right? It's 6.022 times 10 to the 23. It's such a massive number. So this helps us count large amounts of atoms and molecules. So the second main thing to understand here is the conversion factor between AMU and grams. So 1 gram is equal to 6.022 times 10 to the 23 AMU. or atomic mass units. This is the essential conversion for which all of the basis of chemistry occurs. And so you can say that 1 gram is equal to 1 mole of AMU, or 6.022 times 10 to the 23 AMU. So when we want to convert between AMU and grams in the periodic table, we don't actually need to convert anything. So if we have carbon with an AMU of 12.01, then 1 mole of carbon is just 12.01 grams. 2 moles of carbon would be 2 times 12.01, which is 24.02 grams. Let's take oxygen. 1 mole of oxygen, or 6.022 times 10 to the 23 atoms of oxygen, is 16 grams, because we're given 16 AMU here. It's a direct conversion between AMU and grams. So that's all you have to remember. So if we have 10 moles of oxygen, or 10 times 6.022 times 10 to the 23 atoms of oxygen, that would be 16 times 10 grams, or 160 grams. So all you have to remember is that there is a direct conversion between moles and grams on the periodic table. So let's do a practice problem together. A silicon chip has a mass of 5.68 milligrams. How many silicon atoms are there? So the first thing we need to do is convert from milligrams to grams, and then from grams to moles, and then we can use Avogadro's number to find the number of atoms. So let's do that. 5.68 milligrams. And now we need to convert to grams, so we put milligrams on bottom and grams on top. And so 1 gram has 1,000 milligrams. And so now we have converted to grams. And so now we need to convert to moles. So we put grams on bottom and moles on top. And so we need to determine how many grams there are in 1 mole of silicon. So we have our handy periodic table right over here. So if we zoom in, we can see 1 mole of silicon atoms has 28.09 grams. So 28.09 grams. And so now we have moles of silicon atoms. So now to convert to the number of atoms, we can just multiply by Avogadro's number, which is 6.022 times 10 to the 23 atoms in 1 mole. And so if you do the calculations yourself, you should get around 1.22 times 10 to the 20th atoms of silicon. So the key thing to remember here is to always convert when you want to find the number of atoms from grams to moles, and then realizing that there are 6.022 times 10 to the 23 atoms for every mole. Let's do one last practice problem together. Calculate the mass of 6 americium atoms. So whenever it tells you to calculate the mass, you always just assume it wants you to give the answer in grams. So we need to find out the molar mass of americium atoms, or how many grams there are in 1 mole. So if we go down to our periodic table, we can see that 1 mole of americium atoms contains 243 grams. So we can write that down. 1 mole of americium atoms contains 243 grams. So if we have 6 americium atoms, then we have a total of 6 times 243 AMU for those 6 total atoms, since there's 243 AMU per americium atom. So now we have our units and AMU, and so all we need to do is now use Avogadro's number. So you put AMU on bottom and grams on top. And so recall that 1 gram is 6.022 times 10 to the 23 AMU. So AMUs cancel out and we're left with grams. So if you do the calculations, you should be left with 2.4 times 10 to the negative 21 grams. Which makes sense, because we're only wanting the mass of 6 americium atoms, which is almost nothing. So I hope this video helped in understanding moles and stoichiometry a little bit. And as always, please let me know if you have any questions, comments, or concerns.